All right, so we're doing June 2018 in today's class. Um, you guys should have prepared some answers before. If you didn't get all the answers, no problem. We'll sort it out from here. All right, so let's go. So what I'll do is I'll read out the question and you can drop the answers I came up with inside of the chat board, and we correct them and we move through like that. All right, everybody get it? Everybody understand? Just put a Y in the chat board for me and then we get started. Okay, excellent. Great. So let's go. Which of the following processes suggest that matter is made up of minute particles? Right, put your answer in the chat board. Matter being made up of minute particles. Anybody? Right, seen Jadon, right? Seen answers coming in now. All correct answers. Correct. So A, diffusion would suggest that matter is made up of minute particles. All right. Number 2, mass number is the number of neutrons plus protons. A. So another A. Good. 3, when an exothermic reaction occurs, energy is good. Good San, good Navin, good Destiny, Cristiano, well done, Kira, well done. Yes. B, released to the environment, right? And I like to use this little prefix at the X and think like exit, right? So that helps me to remember it. Nice. 4, which of the following statements best describes the difference between an atom and an ion? Difference between an atom and an ion. Good Navin, good Kira, well done Cyan, right? Any others? D is our correct answer. Atoms contain equal numbers of protons and electrons, so there's a neutral charge on an atom, whereas with ions you have unequal numbers of protons and electrons, right? If you have more protons than electrons, then we have a cation. If there's a case where we have more um, electrons than protons, then we have a anion, right? So that's best definition there in terms of the differences. Right, back up to the top. 5. So we're looking at this table, right? 5 to 7 refer to the information in the following table. Which of the following pairs of elements are isotopes? So isotopes, they have different mass numbers. Jaden has an answer. Anybody else? Navin, okay, Kira, Cristiano, Cyan. Right, so the correct answer is C. It's Q and S, right? Q and S, and I'll explain why. Right, so these have the same number of electrons on the outer shell, so we know it's the same element. But the difference between these let me just get a different color, is the mass numbers. Number of protons plus number of neutrons gives us the mass number, right? So the mass number of this one here is 16, but the mass number of this one here is 17. So different mass numbers, but same atomic number, right? So C is our correct answer. Everybody okay with that? 6. Which of the following elements is an anion? Anion. Which of the following is an anion? Navin, Kira, D, Cristiano, D. Yes, that is correct. Correct answer there is D. Right? It's D, T. T is the anion because we have unequal numbers of protons and electrons. All right, more electrons and protons, so we know that's an anion. All right, cool. 7, the element Q. What is the element Q, guys? This one here. All 8s. Anybody have any idea what that element is? Yes, that's correct. That element is oxygen. Right, you screwed up. Right, so correct answer for this one, oxygen. Element Q is oxygen, and we know that because of the atomic number. You could look at the atomic number here and see, and just go back to the table. Right, atomic number, proton number, 8 protons, 8 electrons in the outer shell. Electronic configuration of 2,6. We know that that is our oxygen atom. Good, very good. 8. Barium is below calcium in group 2 of the periodic table. When both metals react with water, the main observed differences would be the rate of the reaction and what else? Rate of the reaction and something else. So you're talking about trends in group 2, but changes as you go down the group. Good answer, Navin. Anybody else? Correct answer is D, the solubility of the product, right? Um, it's more soluble as you go down group 2. Yeah? Solubility increases down that group. Number 9, everybody okay with that, right? Didn't see much responses. Number 9, which of the following aqueous solutions contains 1 mole of hydrogen ions? Just 1 mole. And key thing is hydrogen ions, H plus, 1 mole of that. Right, and pay attention to this bit. This bit here tells us the number of moles in every 1 dm cube. No answers? All right, I'll help you guys out. Um, so first thing you need to look at is one. It's talking about hydrogen ions, right? And automatically, this is the only one here with 1 mole of hydrogen ions. I mean, look at it. It's H plus Cl minus. Everything else, you have 2 moles of hydrogen ions, right? And that's because of these charges here. Again, same thing here, right? And this one, actually, when it dissociates, is not fully dissociate. It doesn't fully dissociate, right? So there are other hydrogen inside there. So my correct answer for this one is actually A, because 2 dm cube of 0.5 molar per dm cube. So 2 dm cubes, 2 by 0.5 gives me my 1 mole, right? And this is a monobasic acid. So you know when it dissociates, you just have 1 H plus there. All right, so correct answer for this one is A. Is everybody okay with that? Just drop a Y in the chat board if you're okay, if you understand. But N if you just want me to repeat. Nope. All right, excellent, great. Everybody's fine on that. 10. Which of the following substances does not conduct electricity? Right, which does not conduct electricity? Number 10. Yes, that's correct, Navin. Anybody else? Ethanol. Ethanol doesn't conduct. Why is that so? Everybody else has either free ions, right? To conduct electricity, you need free ions or free electrons, right? They need something to pass through. Lead provides electrons, copper provides electrons, ethanoic acid provides ions. Ethanol doesn't provide any of the above, right? So my correct answer for this one, right, does not conduct electricity. Ethanol is our winner. C. Yeah. 11. A new element R shows chemical properties similar to the element sodium, right? So it means in the same group. What is the correct formula of a compound formed with R? This is in the new element that you're talking about, and sulfur. Sulfur has a 2 minus charge. It's the correct formula. Yes, correct. Anybody else? Good, good, very good. C, right? Maybe just like sodium, right? So R2S. Excellent. Number 12. 12 refers to information in the table. Which two elements above, when combined with each other, form an ionic compound? Ionic compound means that we have a metal and a non-metal. Metal and non-metal as ionic compound. Right? How are we going to know? Well, we need to look at the electronic configuration of these. Right? 17 is 2, 8, 7, 18 is 2, 8, 8. Right? So kind of crap with 8 there. These here tells us how much electrons on the outer shell. It also tells us which group it belongs to. This one is a noble gas, so that's out. This one looks good. This is a group 1 metal. Yeah, I think that one has it. And then this one is a non-metal, right? So that's out, right? This is a when I say non-metal, this is in group 4, possibly carbon. Carbon is 6, right? So this is probably lithium or something. And we have 287. So 1 and 3, that's going to give us ionic compound. 1 is going to give up an electron to help complete this outer shell, forming a cation and an anion. Right? And that's all we need for ionic compound. Everybody okay with that? Just drop a Y if you understand what I did there. Everybody, Destiny, good. Pure, Cyan, okay, excellent. Everybody's fine. Good. 13, the number of shared electron pairs in the methane molecule, right? Excuse. Methane molecule. So that's carbon and 4 hydrogen like that. Good, good. I think Navin is on it already. Remember carbon, as just saying there, carbon has 4 electrons. If I represent carbon by circles, right, that's the 4 electrons carbon has to give. And then hydrogen, we know hydrogen 1 electron, right? So they're giving up 1. How many electron pairs you guys see in there? Just count them. 1, 2, 3, and 4. Yeah, everybody okay with that? Triple Y. Yeah, excellent. Good. 14. Which of the following statements best describes the formation of a metallic bond? Formation of a metallic bond. You can remember our lattice-like structure that's probably forced to draw. Remember this? Right, let's bring back any memories. What have happened there? Yep, as it the cations held together by C mobile electrons. Good, good, good. Right, so 14 was D. 15, a solution having a pH of 1. What is that solution? Something with a pH of 1. What do you call that? Put the answer in the chat board. Right, acidic. Good. What will an acidic solution do? Will do what? Neutralize a solution of pH 4. pH 4 is still acidic. 7 is neutral. This way is basic or alkaline. And this way is acidic. Right? So this is out. You can't neutralize something of pH 4. I have to neutralize something as above the 7. React with zinc metal to produce hydrogen. That sounds good. Right? Acids and metals. We know gives us salt and H2 gas. Yeah? B sounds good. React with zinc metal to produce a solution of pH 10. That's just ridiculous. React with hydrochloric acid to produce a salt and water. So that's even worse. Acid and acid making salt and water. So correct answer is, let me just clear the screen. Correct answer here is B. React with zinc metal to produce hydrogen. Yeah? Everybody okay with that one? Just drop a Y. So I'll go to move on. Excellent. Good. 16. In the electrolysis of aqueous copper 2 sulfate solution using copper electrodes. Right, so using copper electrodes, you have to pay attention to these things when you see they doing the electrolysis type questions. These are active electrodes. Active electrodes participate. Right, they participate. What do I mean by that? They get all involved in the mix. And once they break up and go into the solution and then probably go somewhere else. So they want to know what happens to the anode. Yes, Navin, you're on to me. Right, so this is one of those reactions when you're like trying to copper plate something. So you have the anode there, it's copper on the side, probably pure copper. Right, the solution inside of here is copper 2 sulfate. Right, so because there's copper inside of here, when we run the current through it, this here, remember at the anode, what's happening at the anode? You're losing electrons, right? Oxidation is happening here. Oxidation is loss, reduction is gain. At the cathode, copper is gaining electrons to become copper solid. Here, the copper inside of here actually loses electrons, right? Becomes copper 2 plus, goes into the solution with this, right? And all those copper 2 plus guys just start to accumulate around here. And as they accumulate around there now, they are reduced and become copper solid. So when you're using copper electrodes, the the anode decreases in mass. And what happens to the cathode? Cathode gets what? Type it in the chat for me. Gets bigger. Yes, it increases in mass. Right, good. Right, so clearing all of that from the screen now. They want to know about the anode, and we just say that the anode decreases in mass. Right, it goes into solution, and the copper then the copper 2 plus ions become copper. They're discharged at the cathode. Yeah, good. So moving forward. Items 17 to 18 refers to this information here. Blah 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 blah. Select the set of elements which fits the following descriptions. Yada yada yada. 17. Which set of elements forms molecules which contain two atoms? Molecules that form, right? Anybody else? Let me give you some hints. Cl2. That's a molecule with two atoms, the same atom. I2. Er2. Where do we find these guys? Chlorine, fluorine, bromine, iodine, right? This guy is 17, 2, 8, 7. Yeah, Navin, Ketchmer, Kira, you want to me as well. Try again there, cyan. Seen it? Group 7. These are elements that form, yep, that's it. C. Correct one for this. Group 7 elements, right? Chlorine, fluorine, bromine, iodine. They form molecules that contain two atoms. They will covalently bond like this and share electrons to complete the outer shell. 1, 2, 3, 4, 5, 6, 7, 8. And then if you check it on the side, bam, 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 bam. Chlorine. Group 7 elements. Okay? Everybody okay with that? Drop a Y. Drop a Y if you understand. Good. 18. Which sets Which set of elements has atoms with 2 electrons in the outer shell? 2 electrons in the outer shell. The group number tells us the number of electrons on the outer shell. Right, that's correct, Cristiano. Good Destiny. Good San. Good Kira. Good Navin. Right, group 2. Right, I'm going to write it here. Group 2. Good. 19. Which of the following statements is true of carbon monoxide? I'll give you a hint here. Think about extraction of iron. Yep, reduction. Think reduction of Fe2O3. This is in metals, on the topic metals. Yes, extraction reactions, extraction of iron. So they use carbon monoxide to reduce Fe2O3 to produce our iron solid. Okay, so D is correct here. This is true for carbon monoxide. Carbon monoxide reduces iron to oxide to form iron solid. Okay, carbon dioxide gas. Good. 20. Adding dilute sulfuric acid to which of the following copper 2 compounds will be the least suitable method for preparing copper 2 sulfate? This is a kind of tricky one. Copper 2 compounds. Think solubility of salts here and think salt preparation. To prepare copper sulfate, what you want is a soluble and soluble base adding to acid. Right, that'll be the ideal method of preparation to prepare copper 2 sulfate. An insoluble base plus an acid. So you have the acid already in the question, right? So now it's just figuring out which are the, so the insoluble base would be a good method, right? They wanted the opposite, the least method. So therefore you're looking for a soluble base. The least, well, least. See? Yeah, that's correct. Actually, no, sorry. Um, Anybody else? You have any other answers? Let me just double check something here. Where's my table? It's actually copper chloride. This one, right? All chlorides soluble. Carbonates are insoluble with the exception of potassium, sodium, and ammonia. Right? Copper oxide has insoluble base too. Hydroxide is another insoluble base. So our winner is copper chloride. All our chlorides are soluble with the exception of silver chloride, and lead chloride is soluble in hot water. It's insoluble in cool water. All right, everybody okay with that one? Remember this one, eh? This is one that they could bring back. Yeah, pay attention to this. Correct answer for this one was the chlorides, and that's because they're all soluble, right? And for the preparation of this particular salt, where is it? We want an insoluble base plus our acid, right? The base is going to provide the cation, right? In this case, the cation is copper 2 plus, and the acid is going to provide the anion. In this case, that. Yeah. All right. Just drop a Y if I could move on. Excellent. Great. 21. Which of the following statements is not true? Not true. Aqueous ammonia is a weak electrolyte. Sulfuric acid is a strong electrolyte. Copper is a strong electrolyte. That's kind of questionable. Ethanol is a non-electrolyte. Copper is when it moves on state to be electrolyte. So the correct answer here is yep, that's right. C. 22. Which of the following techniques may be used to separate a mixture of plant pigments into their individual components? This is similar to like the experiment you guys do with the dye to see. Yes, cyan. Good, Navin. Right. You guys did the experiment, yeah, with the dye and you plot it there and you put the distilled water and then you leave it and you'll see it separate out so you see all the different individual, yeah, that's it. Paper chromatography. Same thing. Pigments, another word for like a dye. Just playing games with the words. Right. 23. Which of the following compounds is reduced? Reduced. So you all need me here? Tell me. So a good way of always doing these redox reactions is to go with some of the common things, you know. So you see all these set of oxygen all over this. That's a good starting point. Oxygen generally has a oxidation state of -2. So it's like allow it to decipher whatever else is bonding with what oxidation state that might have. So like for example with this one here, right? I have two oxygens. So that means that's two of these. So overall I needed a -4 charge in order to balance with this N here. So that tells me that this N here carries a charge of +4. Right? Make sense? Very okay there? Follow me with that? Good. So then let's look across here now. Something changed. Now we have NO. So I just said that oxygen generally has the, or usually has the charge, where's my pen? Oxygen usually has the charge 2 minus, right? Except in the case of peroxides. So now that we just seen one over here now, that tells me that this went to 2 plus, right? Now remember this number here is based on the difference between protons and electrons. If I have more protons than electrons, then I'll have an overall positive charge if protons is greater than electrons, right? So for me to go from +4 to +2, it meant that I had to gain more electrons, right? For me to go from +4 to +2, I had to gain, I'll write the word gain, 2 electrons. So that reduced this now. 2 more electrons will kind of take out two of these positive charges. So now only left with the overall +2. So since I gain electrons, and we know this mnemonic called oil rig, which is so very helpful. We know that reduction occurred here. They gained electrons in order for this to drop lower, right? So which of the following compounds was reduced? NO2 was reduced to NO. This is the one that was reduced, right? And as we add it, whichever is reduced, whatever is reduced is called the oxidizing agent, right? And whichever was oxidized is called the reducing agent. Can I get a different color? Let's look at this one, right? Same premise here again. Oxygen is usually -2. So if I have two of them here, that's telling me that this had to be a +4. Now look at this here. Now I have three oxygens here, right? So usually that's -2. So that means that this went to +6, right? For this to go from +4 to +6, it meant that it lost more electrons, so then now more protons. That's why I had an increase in the oxidation charge. So this one, right, was oxidized. And if this was oxidized, then this one is the reducing agent. Everybody get that? Just drop a Y if you did. Good. Right. Excellent. Good. So I'm going to just scroll up a bit. Next question, same equation. They want us to know which of the following is the oxidizing agent. Well, I kind of already tell you that already, right? Because this one here that was reduced is the oxidizing agent. See it? This fellow here. Okay. Right? So this is the oxidizing agent here, right? And it was reduced. Yeah? So which of the following compounds is reduced? NO2. Scroll up. Which of the following is the oxidizing agent? NO2, because that was reduced. Yeah? Good. Next one, 25. Which of the following substances, when added to pure water, significantly increases the water's conductivity? Increasing water's conductivity. So electricity needs either electrons to flow through a substance or ions. Good enough, that's correct. Sodium chloride or table salt. This is the salt that is put in your eggs and making breakfast. Right? If we add salt to water, that increases its conductivity because now there's sodium plus and Cl minus. There's ions inside of the water, more ions, right, than just the H plus and the OH minus. Right? So this allows it to conduct electricity. Yeah? So D, sodium chloride. Good. 26. Which of the following diagrams best illustrate the course of an exothermic reaction where it gives heat off to the environment? So it means that the product should be lower than the reactant. A. Sorry, I didn't show the entire thing. Right? A is correct. Products lower than the reactants. You have a negative change, enthalpy change. Yeah? Released to the environment. Nice. 27. A substance Y reacts with an ammonium salt to produce ammonium gas. Y must therefore be a base. Right? A base for this one. Right? The ammonia salt reacts with the base. You're going to get the ammonia gas, NH4. Did you write to that one? Good. 28. An example of a substance with a giant covalent structure. This is an easy one. You all would know this. Giant covalent structure. Remember this diagram. What's this diagram? Good. Diamond. Giant covalent structure. Right? It's carbon and hydrogen. Right? So this one is B, diamond. 29. An ion with a single negative charge may be converted into a neutral atom of the same element by what? How is it going to become a neutral element? So if I have a good, right? If it have a negative charge of +1, right? Let me just say is let's make up element minus, right? It means there's more electrons than protons, right? So if I'm using an example, I could say this has 4 protons and this has 5 electrons. So the difference between these two, if this is a +4 and a -5, is -1. Right? That gives me the single negative charge you're talking about here. In order for me to get this to be a neutral charge, then it needs to be +4 +4 +4 -4. So my overall charge is 0, right? So it becomes a neutral atom of the same element. So I need to lose an electron. Yeah, make sense? Right? Lose the electron to become a neutral atom. Let's rub off some of these, right? For it to be negative, right? 1, the electrons, there's my pen, electrons has to be more than protons, right? So here is negative because the electrons is greater than the protons. Here is neutral, this is neutral because our proton is equal to our electrons. +4 -4, they cancel each other out, 0 charge. Yeah, good. 30. On adding aqueous hydrochloric acid to a solution in a test tube, a gas is given off which extinguishes a burning splint. This shows the presence of what extinguishes a glowing splint. As identification of gases there for you. Anybody remembers? You could do a process of elimination there. Because I don't think we would have done um, yeah, carbon dioxide. They just try to confuse you with the ions. Yeah, it's carbon dioxide gas. It will extinguish your burning splint. Burning splint need oxygen to continue burning. That's why, like in fire extinguishers, they use carbon dioxide in some of them. It's out to fire. Yeah, everybody okay with that? The main substance responsible for acid rain. What's the main thing responsible for acid rain? Main contributors. Yep, that's correct. Sulfur dioxide and sulfur trioxide, right? Acid rain. Just going to get this stuff like sulfuric acid. Yeah, everybody okay there? Going on to 32. Right, 32. These are brown gaseous oxide which is soluble in water. It turns moist blue litmus red. Z may best be described as a, this is your big key here. What turns blue litmus red? Yep, something that is acidic. Right, is the other way around for basic. Right, acidic oxide. 33. Sulfur is used in which of the following processes? To do another process elimination here. Iron, what was used for iron? Iron is air, the iron ore, coke, right, the carbon monoxide, and limestone, calcium carbonate. So that doesn't use, you can take that out. So anything with 2 in it was wrong. So that's gone, this is gone, this is gone. Oh, look at that. There we go. 1 and 3. B. Yeah. So you could kind of reverse engineer answers too for these, right? If you're not sure about something, like if you already didn't know that sulfur is used inside of these, you could use what you know and then isolate and sometimes try to get it to answer. Yeah? So a correct answer for this one is B, 1 and 3. Vulcanization of rubber uses sulfur and the manufacture of explosive uses sulfur. Right? 54. Which of the following metals will not displace hydrogen from dilute hydrochloric acid? You have zinc, iron, copper, aluminum. This one is your reactivity series. We had this mnemonic that we used to learn. People sometimes collect magazines about zoos in London having cute monkeys and small gorillas. You all have any mnemonics like that? The name of the reactivity series? Nope, none. I probably put it in the group. But I have a couple, I mean, just have them on the internet and thing. So any answers to this one? Any answers? So let me just write here. So aluminum, zinc, iron, and there's lead. All below, I mean, now there's hydrogen, copper, right? Most reactive to the top. C, good. Yeah, it's kind of hard to tell with the if you put a number, it's kind of it's get confusing when I take my eyes off the chat and then go back. Yeah, so it is copper. Yeah, please stop calling Marcus Zuckerberg in London. He's called Suk. Okay, all right, that's a cool one. That's a new one. Yeah, so yeah, you are right now. Gonna see copper, right? Can't. Copper is below hydrogen. Right, hydrogen is here, copper is underneath it. You can't. Nice. Right, so everybody's good with that. 35. Which of the following lists contain all the raw materials used in the extraction of iron? I kind of gave this away early on. All raw materials used in the extraction of iron. What do we need? And we saw a question before where we know the carbon monoxide, which is cool. Yep. C. Again, nothing. So that one. So C, air, coke, iron ore, and limestone. These are all the materials that you're going to use in the extraction of iron. Right? Just go on the screen. Good. 36. A property of metal is that they tend to what? It's not difficult. All metals lose electrons, form negative ions as not true. Be resistant to the passage of electricity, that's not true. Yep. E. Be discharged at the positive electrode line, right? So A, lose electrons. All metals lose electrons because they are in group 1, 2, or 3, and they lose electrons to form positive 1, positive 2, or positive 3 cations, right? Because they all either have 1 electron, 2 electrons, or 3 electrons on the outer shell, right? E. 37. Which of the following procedures can be used to identify ammonia gas? How do we identify ammonia gas? Good. D. Placing red and blue litmus paper in a jar. Good. You're probably did that experiment. It's good. Number D. Very good. Next, 38. Why is aluminum more resistant to corrosion than iron? Why is aluminum more resistant to corrosion than iron? Why do we use aluminum plated objects? Right, good, very good. Nothing, Cristiano. Aluminum oxide protects the aluminum, but the iron oxide does not. Yep, very good. Good job, Kira. That's correct. 39. Which of the following diagrams best illustrate bonding in hydrogen bromide?
hydrogen bromide, group 1, group 7. Right. So just think about the, yep, D, right? Bromine, this one will be the bromine, this will be hydrogen, hydrogen just having 1 here, see it? Bromine have 7, 1, 2, 3, 4, 5, 6, 7 electrons, sharing this here, ionic bond, hydrogen bromide, D, yeah? 40. How many covalent bonds are there in a nitrogen molecule? Nitrogen molecule. Nitrogens, give you the electronic configuration. Nitrogen is 7 electrons. Right, so that's what, 2 and 5. So 5 on the outer shell. 1, 2, 3, 4, 5. And so how much more electrons it needs to fill it? It needs 3 more. Right? So it's gonna have B, 3 covalent bonds. Make sense? Yep. Oh, you'll add the B there. Good. Excellent. Good job. 41. Let's go on to 41. Right. So 41 refers to the following table, which shows the reaction of 4 metals, W, X, Y, and Z, with water or steam. Right. The table also shows the products formed when nitrates are heated for each metal. Right. Let's see the questions they have. Which of the metals is likely to form a soluble hydroxide? A soluble hydroxide is like group 2 metals. So let's look at them. This has no reaction with water or steam, right? This one reacts with steam but not with cold water, right? This reacts quickly, rapidly with cold water. So this is the most reactive here, right? This one reacts slowly with cold water. So this is still happening. Yep. Now when it's on soluble hydroxide would be this most reactive guy here, C. Yeah. This would be the second most reactive, Z. Then this one and then W last. Yeah. Pretty good with that one there. 42. Aluminum is manufactured by electrolysis of pure molten aluminum oxide, while iron ore is manufactured by the reduction of its ore hematite, Fe2O3. Which of the following statements about aluminum and iron is correct? Iron is more reactive than aluminum. Nope, that's not true. We're just looking at the reactivity series. Aluminum is more reactive than iron. Yep, that is true. Iron cannot be obtained by electrolysis. Electricity is cheap near aluminum oxide deposits. That's ridiculous. Correct answer is B. Right? Aluminum is more reactive than iron. It is. Good. 42. And we are on to 43. Which of the following substances is an important constituent of chlorophyll? Gives it its green color. Any idea? Yes, good job, Jadon. D. Magnesium. Very good. 44. Which of the following metals will not react with water under any conditions? Will not react with water at all. Yep, that's correct. Copper. Copper wouldn't react with water. Very unreactive. It's low in reactivity series. Yeah? 45. Which of the following metals forms an oxide which cannot be reduced by hydrogen? Same thing again, reactivity series. Cannot be reduced by hydrogen. And now they send you all that table with the reactivity series. Good, very good. Copper, C. Yeah, below hydrogen. Moving on, 46. 46 to 47 refers to the following compounds. We have natural gas, propene, ethanol, vinegar. Each compound may be used once, more than once, or not at all. 46. Which of the following compounds contains a saturated hydrocarbon? Saturated. Right? Unsaturated is the presence of a double bond. Remember that. Alkenes are unsaturated hydrocarbons. Alkenes are your saturated. Actually, propene is your alkene. This is an example of an unsaturated, right? Natural gas is actually methane, right? Which is an alkene. And we know alkenes are saturated hydrocarbons. Right? So the correct answer for this one contains a saturated hydrocarbon would be E, natural gas. Yeah? Everybody alright with that one? Nice. 47. Which of the compounds can be dehydrated? What can we dehydrate? Alcohols are dehydrated. Back to alkenes. Right? Anytime you see the word dehydrated, dehydrated is, just think about it, when you're dehydrated, you just don't have enough water. Alcohol has that OH group. So what you're doing is you're removing that, you're dehydrating it, you're removing that OH group. They usually use concentrated sulfuric acid and they boil it, right, 170 degrees Celsius, and that removes this OH, and where that OH goes, you actually get double bond forming there. Right, so correct answer for this one is C, ethanol. Yeah, good. 48. How many isomers of butane C4H10 are there? Number of isomers. Isomers are similar structural formula. 1, 2, 3, 4. You should then have hydrogen like that. Two, not too good there. right? So that's one, and then I could do like so. I could put one guy there, and that's about it. Because if this is the same thing, if I put one underneath here, right? Um, this putting it on the end doesn't. It's the same. This and this is the same, right? Let me just do that again. So isomer has a different structural formula. They both, all of them would have the molecular formula C4H10. But when we draw in it, right, they could be drawn differently. So you could draw it as a straight chain compound like this, four carbon um, in a straight line like this, or we could move one of these groups, right? Now I can't move the group like right here because that's just like rotating it. If I just put this here and a H come here, I didn't change anything. I just move it on the same carbon, right? Something that's totally different would be like this. If I put it there, right? This is on the second carbon atom, right? If I try to draw it and I put it underneath here, it's still the same thing. It's just like the mirror image of each other, right? So you can say that this is a totally different isomer. So the correct answer for this one is B2. Yeah? Everybody alright with that one? Do you understand now? For why if you did? Good, good. Jaden, you alright? You understanding, right? You have any questions? You can private message to in the chat, eh? 18. 18 cannot be directly converted to what? Alright, nice. Curious, good. Jaden's good. What you can't directly convert it to? So meaning that, alright, for example, ethane could go directly to ethane. We could get rid of the blah 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 double bond. That's called hydrogenation, right? So we could move from ethene straight to ethane. That's possible. Um, you could go from ethene to ethanol, right? You can't do that. You could go from ethene and get carbon dioxide. If I burn ethene, ethene is a gas, you would get carbon dioxide. But I can't go directly from ethene to ethanoic acid, right? Acids I would have to get from the alcohol. So I have to go from ethene to ethanol and then from ethanol to ethanoic acid. Yeah? Everybody get on? Yep, D. D is the correct answer, ethanoic acid. It's not a straight path from ethene to ethanoic acid. I'll have to convert from ethene to ethanol first, right? And then from that, I could then move on to forming the acid. That's the correct answer for this one is D. Good. 50. Which of the following structures represents a molecule of but2-ene? So the ene is the functional group. It tells me which homologous series it belongs to. So this is a, um, a alkene for 18. This is a alkene. 2 tells us the position where it is at. So if we check any carbon from left to right, 1, 2, 3, 4, then it should be on by the second one here, right? If I check it from the opposite way, 1, 2, right? If I check 1, 2, so either there or there, 2. Right, I think now there's on to me there. But, met et prop but. So I don't know your prefixes as well. Met is 1, et 2, prop 3, but 4, pent 5, going on like that. So butene is 4 carbons. 1, 2, 3, 4. I just said 2. That's telling us where the functional group has to go. So 1, 2. Right? This is 2 and 3 here. Right? This one here, 1, 2. But this is not but. This is 1, 2, 3. This is prop. So this is wrong. This is wrong. Right? And this is on both 2 and 3. I don't know what this is. Right, this is wrong as well. So my correct answer is E. Yeah, 51. So referring to these things up here, right? This 51. Which of these substances is soluble in water? Was soluble in water there? The answers? Soluble in water. So let me give you some ideas. Julian says B. B is an alkene, right? So organic compounds, kind of successful. These are usually like with organic solvents, right? This might be a gas, propene. This is three carbons, so this is probably not liquid at room temperature. This one here, this is a propene, so another gas, and this is a ester. Alcohol, this guy here, right? A, yeah, but it's alcohol in water, you would know. Yeah, these all soluble. Yeah, so A for this one. This one will be A, right? 52. Which of these substances is used as a monomer in addition polymerization? Monomer. So this is like the monomer units, and you use that to build these long chain hydrocarbons. What do we use? Addition, the secret ring of it. Addition polymerization. Using unsaturated compounds. Unsaturated. Unsaturated means double bond present. Mm-mm, not C. C is CnH2n plus 2, right? So C3, and then 3 2s are 6 plus 2 is 8. So this is a ane as methane. Yep, it's B. Yep, that's it. This guy here. See what happens is you need these in order to make the polymers. What's happened is um, when the bond breaks, they have the free electrons which continue to attack other double bonds, and as well as cause a long chain to form the polymers, right? So for 52 substance using them as a monomer unit in addition, so there are two types of polymerization. You have addition polymerization, and the other one is condensation polymerization, right? The only monomer unit that does addition polymerization is the alkene. This one here is the key giveaway. Only alkenes do addition polymerization. Apart from that, you have condensation polymerization, right? And these are like your polyamines or amides, your polyesters, your polysaccharides, right? These are condensation polymers. Addition polymerization alkenes. Yeah, right. About 53. The major natural source of alkenes and alkenes. Major natural source of alkenes and alkenes. It's a major source of it. What do we refine? What do you used to refine in petrochem? Natural gas. Yep, good. Well, not petrochem. Petrochem used to do crude oil. Right, 53. Well, actually, natural gas would just be a CH4. The better answer for this would be a petroleum, because you would take the large alkenes and alkenes and you would break it up during that in the fractionating column. Remember that? So the better answer for this is E, petroleum, natural source, alkenes and alkenes, both of them. Yeah, natural gas, you will have the alkenes coming in there. Everybody alright with that one? Remember that, right? Petroleum. So go with the natural gas. 54. When a hydrocarbon molecule is cracked, see, and we're now talking about it here, which two smaller molecules are produced? Now talk about that here. Alkenes and alkenes. Large hydrocarbon molecule cracked. Yep, that's it. Very good, Cristiano. Navin, good. 1 and 2. Alkene and alkene. Yeah, good. Not bad. 55. 55. The forward reaction is known as going for acid and alcohol to get a ester and water. What do you call that? Starts with this word. Yep, that's it. Moving from organic acid and alcohol to get to, yep, that's correct. Very good, guys. Esterification. And the reverse, if you go in the opposite direction, we're going from the ester and the water to get back what we started with, the acid and the alcohol. That one we call hydrolysis. Yeah, that's the reverse of it. So forward is esterification to make the ester, and then you can do acid or alkaline hydrolysis of the ester, and it gives you back the acid and the alcohol. Yeah, good. 57. Which of the following features is not true of all homologous series of compounds? Not true. They all have the same functional group. That's true, right? Same general formula. Yep, that holds. Similar chemical properties. Yep, that holds. So, well, process elimination. D. Same empirical formula. Not true. Yeah. 58. The fermentation of sugar using glucose as a substrate can be represented by which of these equations? Glucose is C6H12O6. And you need oxygen. And you get energy, carbon dioxide, and water. Actually, looking at fermentation, yes, it's not oxidation. Fermentation of sugar, we're producing alcohol. This is my glucose molecule. Right, remember functional group for alcohol has my OH functional group in it, so looking for something with the functional group OH. Yep, and usually the byproduct of fermentation is carbon dioxide gas. Right, carbon dioxide gas and alcohol. Yep, that's correct. See, right, this is the glucose I was telling you about here. See it? And looking for many alcohol, ethanol and carbon dioxide gas. So C is my correct answer. Yeah. 59. To which homologous series does the following structure belong? Uh, Functional group A. Yep, carboxylic acids. Right, very good. Last question. Oh, here it goes. 60 refers to the following graph which shows the boiling points of some straight chain alcohols. Which of the following molecular formulae represents the alcohol whose boiling point is 160 degrees Celsius? So let me just make this a little bigger. 160 degrees. So 60, 70, 80, 90, 200. Good. So they're talking about here. Right. So see where I line up there? get a different color, purple, and down, boom, there we go. So which one? So it was six. Zoom out, so I lost that there. So six carbon atoms. Which one is it? Let's see. One. Oh boy. Why isn't that good? I'll make this bigger. You're seeing, right? So one and three. This is only five carbons here, so that's out. One and four. This is another five, so that's out. One and five. Six carbons, so this is possible. One and five. This is six carbons. What's different? Is that no wait? This is six here. So this is seven carbon atoms. Correct answer is yes. That's correct. C. Right, this one. Let me check 160 across. It lines up directly here. See? All right, guys. Anybody have any questions? Any number I want me to go over? Any other question I want me to go over from this paper? Anything I want me to explain again? Don't be too discouraged, right? The papers tend to repeat some of the questions, a lot of the questions. So the plan is to do as much as possible. One other surprise paper here for us, just in case we had finished a little early. We still have a little time before 7. So we could look at some more papers. This is Jan 2019. This is Jan 2019. Which of the following processes demonstrates that matter is made up of minute particles? This is a straight repeat from what we was doing before. Which one, guys? Matter made up of particles. We have diffusion. Right, okay, good. Everybody has diffusion. Right. In the notation Cl 3517, the subscript 13 represents what? Atomic number, oxidation state, mass of a mole of atoms, atoms in a mole of molecules. Just get rid of the stuff that don't make sense. Right? Get rid of that. Oxidation state, you know, is like positive, negative. So you can do a process of elimination there. Very good. E. Right? That's my correct answer. Good. Number 3, from the table below, which of the following substances represented by the options A, B, and C, A, B, C, D is most likely sodium chloride, right? Sodium chloride, anytime you see this, remember this is salt, table salt. Now, table salt conducts electricity in its molten state or in its aqueous state. Yeah? So if I dissolve salt in water, yes, it will conduct electricity. So looking for something that's conduct electricity in its aqueous state. So that automatically gets rid of these two. But sodium chloride is an ionic bond, so it's going to have a high boiling point. So this is what we're looking for. So yes, C is correct, Navin. Also now everybody understand that one? Process elimination there, or it's about doing now. Yeah. Everybody else, you're good? Jadon, good. Kira, you alright? Understand that one? Alright, good. 4. For this one. Connect everyone, send a spaceship to Mars here. The salt whose solubility changes to the greatest extent in the temperature range 0 to 60. So in the range 0 to 60, they kind of sell up this out there. They're just talking about within this range. So let's take this and go up here, right? That kind of narrows stuff down for us. With salt solubility changes to the greatest extent, but with salt only stays in this range. You understand? Sometimes don't let them intimidate you with the question, the diagram and all that. There's only one salt that stayed in the range 0 to 60. Which salt is that? Yeah, B, potassium nitrate. Yeah. So see, we didn't even have to think, right? Don't let them confuse you. Like to play games with the English language. Which of the following substances supplies protons as the only positive ions in aqueous solution? Right? Now, hint here is when hydrogen loses the electron, it becomes a what? Technically, the cation H plus is a proton. This is no electrons, it's only protons, right? And which of these substances you know liberates H plus ions? Salts? Nope. Salt is acid. Hemi acid is our metal and non-metal. Bases? Nope. Acids? Acid sounds good. Alkali? Nope. So it's no answer. C. Acids. Right, remember acid is a H plus or proton donor. Right? HCl, HNO3, H2SO4, H3PO4, right? What again? CH3COOH. All of them H's, H. Yeah, proton donors, H plus donors. 6 crystals of sodium chloride. Where's sodium chloride again? Sodium chloride is table salt, right? Just keep in mind yourself for that. Are best described as ionic sodium chloride, Na plus Cl minus. Positive cation, negative anion. Right, that's the characteristics of a ionic compound. Yeah, A. Good. Let's go again. 7. The ionic equation for the reaction between an acid and a carbonate is represented by what happens when you react an acid and a carbonate. Acid plus carbonate gives a salt, carbon dioxide, and water. Right? The acid is the one given the H plus, the carbonate is the one given the CO32 minus, and you'll get some salt, which they wouldn't write. And your water. Right? So these two are out. Toss up is between these two. Right? Pay attention to your number of H plus ions. Yep, you see it. You need 2 of these here. Right? So you need 2 of these here to get more whatever the salt is. Remember, it's an ionic equation. So when you write in the ions, the salt is not ion, right? And then you did keep your gases. So we're gonna have carbon dioxide gas. I have one C here, 2 O's, and then I have H2O. The extra O from here, this is that, right? But then this not balanced because I only had one H here, so that's why I needed to put a 2 here. And that's why this is the correct answer. Yeah, let's carry forward this one, right? H. That's my right answer there. See, all right. 8, you just get up to 10. You go up to 10 and then this is a little more intense, right? Um, like I said, do have no fail. Just for you guys to practice. Do the past papers over. So um, I'm assuming you're not writing the answers down while you're working out, right? And you just continuously keep doing over the papers, and the question to repeat. So 8. When 100 centimeters cube of 2 moles per dm cube hydrochloric acid in excess are added to 5 grams of granulated zinc, hydrogen gases evolve at a certain rate. We take the same 5 gram, but now it's powdered zinc, with a reaction. We use instead the rate of the production of hydrogen gas would do what? Powdered zinc. Right? It would increase. It would not because of concentration. What happens when you powder, when something becomes powder? Right, greater surface area. Right? Right? Greater surface area. Increase surface area. Yeah? 9. An element X has an electronic configuration of 281. At which of the following positions is the element in the periodic table? Right? The last number tells us the group, right? And the number of shells tells us the period, right? So if I have something as 283, I know it's in period 3, right? Because there's one shell, two shell, three shells, right? And this tells me the group number. Yeah, let's see. Last one, right? If we face to this table, I'd ask us which of the following properties above refer to a neutron, right? So a neutron has no charge, no charge. So relative charge 0, right? But the mass of a neutron is 1. Yep, B. B is the correct answer, right? Neutron is no charge with approximate mass of 1. And what about a proton? A proton has 1 positive charge, and the mass of a proton is 1, 1 atomic unit. Okay? So this one is B, and then this one is A. Proton. So I was going to stop at 10, stop at 11. Alright guys, so that's going to conclude our class for today. Let me just stop the recording.